The search for extraterrestrial life has long been a topic of fascination and scientific inquiry. For centuries, humans have wondered if we are alone in the universe or if there are other forms of life out there. With recent advancements in technology and space exploration, we are now closer than ever to answering this question. One promising avenue for the search for extraterrestrial life is our own solar system. In recent years, scientists have discovered evidence that suggests there may be microbial life on other planets or moons within our solar system. This video will explore the possibility of extraterrestrial life within our own solar system and examine the latest scientific discoveries and research related to this topic. We will take a closer look at Mars, Europa, Enceladus, Titan, and other celestial bodies that may have the potential to harbor life. The implications of finding extraterrestrial life within our own solar system could be profound, and could change our understanding of life in the universe forever. The topic of this video is the possibility of extraterrestrial life within our own solar system. With recent discoveries and advancements in space exploration, scientists are now investigating the potential for life on other planets and moons in our own solar system. This video will provide an overview of the scientific research and theories related to this topic, and examine the evidence that has been found so far. The search for extraterrestrial life is important for several reasons. First, it could help us answer one of the most fundamental questions in science: are we alone in the universe? The discovery of extraterrestrial life, even if it is only microbial, would be a monumental scientific breakthrough that could have far-reaching implications for our understanding of the universe and our place within it. Second, the search for extraterrestrial life is important because it could provide insight into the origins of life on Earth. If we can find evidence of life on other planets or moons, it could help us understand how life evolved on our own planet. Finally, the search for extraterrestrial life is important because it could lead to the discovery of new technologies and resources that could benefit humanity. For example, if we can find evidence of microbial life on Mars, it could help us understand how to create sustainable habitats on other planets, which could be useful if we ever need to leave Earth. Mars has been a primary target in the search for extraterrestrial life due to its similarities to Earth. Numerous space missions have been sent to explore Mars, including the recent Perseverance rover mission. The exploration of Mars has revealed that it was once a much wetter and warmer planet, with a thicker atmosphere and flowing water on its surface. The possibility of microbial life on Mars has been a topic of discussion for many years. While the harsh conditions on Mars make it unlikely that complex life forms exist, there is a chance that microbial life could exist in the planet's subsurface. In 2015, NASA announced the discovery of evidence of liquid water on Mars, which provides a potential habitat for microbial life. The recent Perseverance mission also includes the search for signs of microbial life. Evidence of water on Mars has been found in various forms, including frozen water in polar ice caps, subsurface ice, and evidence of flowing water in the planet's past. In 2015, NASA announced the discovery of hydrated salts on Mars, which indicated that liquid water may be present on the planet's surface during certain seasons. The presence of water is important because it is a key ingredient for life as we know it. The discovery of water on Mars has increased the possibility that microbial life may exist on the planet. Europa is one of Jupiter's moons and has been a target for space exploration due to the possibility of a subsurface ocean beneath its icy surface. The first spacecraft to visit Europa was the Galileo orbiter in the 1990s, which provided valuable data on the moon's composition and geology. The European Space Agency's upcoming Jupiter Icy Moons Explorer, JUICE, mission is set to launch in 2022 and will focus on the exploration of Europa. The possibility of subsurface oceans on Europa has been a topic of interest for scientists for many years. In 2013, data from the Hubble Space Telescope provided the strongest evidence yet of a subsurface ocean on Europa. The ocean is thought to be beneath a layer of ice that is tens of kilometers thick. The presence of the subsurface ocean is important because it could potentially harbor life. The ocean is heated by tidal forces from Jupiter, which could provide the energy needed to sustain life. The upcoming JUICE mission will focus on studying the subsurface ocean and the potential for life on Europa. The subsurface ocean on Europa has been of particular interest to astrobiologists as it presents a potential environment for life to exist. The ocean is thought to be around 100 kilometers deep and is kept in a liquid state due to tidal heating generated by the gravitational pull of Jupiter. The potential for life on Europa is supported by the fact that microbial life has been found in extreme environments on Earth such as deep-sea hydrothermal vents and subglacial lakes. These environments are similar to Europa's subsurface ocean, where temperatures are below freezing but liquid water is present. The ocean on Europa is also believed to contain dissolved salts and minerals, which are important for the formation of biological molecules and could provide a source of energy for life. In addition to the subsurface ocean, there are other factors that support the potential for life on Europa. For example, there is evidence of a rocky seafloor, which could provide the necessary chemical gradients for life to thrive. There are also regions on Europa's surface where plumes of water vapor have been detected, which could provide a source of organic material for life to use. Enceladus is one of Saturn's moons and has been a focus of scientific exploration due to its intriguing geology and potential for life. The Cassini spacecraft conducted multiple flybys of Enceladus, providing valuable data on the moon's composition, geology, and potential habitability. The data revealed that Enceladus is geologically active, with icy plumes emanating from its south polar region. The Cassini mission also discovered evidence of a subsurface ocean beneath Enceladus' icy crust. The ocean is believed to be global and is kept in a liquid state due to tidal heating generated by Saturn's gravitational pull. The ocean is thought to be in contact with the rocky seafloor, providing the necessary chemical gradients for life to exist. For life on Enceladus is supported by the discovery of complex organic molecules in the icy plumes emanating from its south polar region. These molecules include nitrogen and oxygen-bearing compounds, as well as amino acids, which are the building blocks of proteins. The presence of these organic molecules suggests that Enceladus could potentially support life. In addition, the discovery of hydrothermal vents on the seafloor of Enceladus' subsurface ocean has further bolstered the potential for life. On Earth, hydrothermal vents support diverse ecosystems that are not reliant on sunlight and instead rely on chemical energy. the hydrothermal vents on Enceladus could provide a similar environment for life to thrive. Titan is the largest moon of Saturn and has been the subject of scientific exploration due to its unique atmosphere and potential for habitability. The Cassini spacecraft conducted multiple flybys of Titan, providing valuable data on the moon's composition, geology, and atmosphere. The data revealed that Titan has a thick atmosphere composed mostly of nitrogen, with methane and other hydrocarbons present as well. The possibility of hydrocarbon-based life on Titan has been explored by scientists due to the moon's abundance of methane and other hydrocarbons. While life as we know it on Earth is based on carbon and water, it is possible that alternative forms of life could exist based on different elements and molecules. In theory, life on Titan could be based on methane instead of water, with hydrocarbons serving as the building blocks of biological molecules. Evidence of a subsurface ocean on Titan has been suggested by data from the Cassini spacecraft. The data showed that the moon has a weak gravitational field, suggesting that it is not entirely solid. Additionally, there are regions on Titan's surface where the topography appears to be inconsistent with a solid interior, suggesting the possibility of a subsurface ocean. The potential for life on Titan is further supported by the presence of liquid methane and ethane lakes and seas on its surface. While the lakes and seas are not composed of water, they could potentially provide a habitat for life adapted to the unique conditions on Titan. Ceres is the largest object in the asteroid belt between Mars and Jupiter and has been the subject of scientific exploration due to its intriguing composition and potential for habitability. The Dawn spacecraft conducted multiple flybys of Ceres, providing valuable data on the dwarf planet's composition, geology, and potential for life. The data revealed that Ceres has a complex geology, with evidence of water, ice, and salts on its surface. Additionally, the presence of organic molecules has been detected on Ceres, suggesting the potential for life. Pluto is a dwarf planet located in the Kuiper belt beyond Neptune and has also been the subject of scientific exploration due to its unique composition and potential for habitability. The New Horizons spacecraft conducted a flyby of Pluto in 2015, providing valuable data on the dwarf planet's composition, geology, and atmosphere. The data revealed that Pluto has a diverse geology, with evidence of water, ice, and other volatile compounds on its surface. While there is currently no concrete evidence of life on Pluto, the potential for habitability cannot be ruled out. Other potential candidates for life in the solar system include the subsurface ocean of Ganymede, one of Jupiter's moons, which has been detected by the Galileo spacecraft. The subsurface ocean of Callisto, another of Jupiter's moons, which has been suggested by data from the Galileo spacecraft. The subsurface ocean of Titan, which has been suggested by data from the Cassini spacecraft. The subsurface ocean of Enceladus, which has been detected by the Cassini spacecraft and shows potential for life. The subsurface ocean of Europa, which has been detected by the Galileo spacecraft and shows potential for life. Thank you for watching our video on the possibility of extraterrestrial life in our solar system. While we have only scratched the surface of this fascinating topic, it's clear that the search for life beyond Earth is more important than ever. By continuing to explore our solar system and beyond, we may one day find definitive evidence that we are not alone in the universe. Don't forget to like and subscribe for more videos on science and exploration. Thanks for watching. Don't forget to like and subscribe for more videos on science and exploration.